In this video, I will show you how to simplify complicated exponential expressions like this one. Two things that you have to watch out for, two rules. You cannot have negative exponents. So if I get n to the negative 2/3 power, I cannot leave it like this. Instead, that negative exponent means it's on the wrong side of the fraction, so I would drop it down to the bottom and I would have n 1 over n to the 2/3 power. But that brings me to the second rule. You cannot have a fractional exponent in the denominator. In the numerator it's okay, but not the denominator. So we have to find a way of fixing this, which I've done in the last 3 videos. And if it comes up in this problem or the next problem, I will show you how to fix it again. This is problem number 21. I've done problems 1 through 20 on previous videos, so if you're going straight to number 21, you might want to go back and watch some of the older videos. So I will start with the numerator. I see an A and an A. When you multiply, you add the exponent. So I need to do 1 plus 1/3. So this is like 1 over 1. So I could make like denominators like this. So that's going to make 4 over 3. So I will have a to the 4 over 3 power. So far so good. What about b? Okay, so looking at the b's right here and here, again I need to add those exponents. So I need to do 5 over 3 plus negative 2, over 1. So again I need like denominators, so this will be 5 over 3 plus negative 6 over 3, so that's negative 1/3. So I have b to the negative 1/3 power. Alright, time for the c's. So I need to do 2 plus 2/3. Okay, I can make like denominators, so this is 6 over 3 plus 2 over 3, so that'll be 8 over 3. So I've got c to the 8 over 3 power. That is my numerator. Now I'm going to start getting to work on the denominator. Okay, I see the c to the 0 power. Alright, that's going to just become the number 1. So really that's gone. So that just leaves the other two variables raised to the second power. When you raise a power to a power, you multiply. 1/2 times 2 is 1. So this will be just a to the 1 power, which is just a. Now when I do 5/4 times 2, that's going to be 5/2. Okay, and I'm multiplying. So 5 over 4 times 2 over 1. Now I look at this and go 2 goes into 4 twice, so I get 5 over 2. If you don't like that, then you might think of it as 5 times 2 is 10. So that's 10 over 4, which reduces down to 5 over 2. Whichever way you want to go. It's fine with me. Okay, so that's what we have so far. So we have to clean this up by subtracting. When you divide like bases, you subtract the exponents. You can think of this as a to the 1 power. So what I'm about to have to do is I need to do 4 over 3 minus 1, or minus 1 over 1. If I go ahead and make like denominators, this is really 4 over 3 minus 3 over 3. So that's going to be 1 over 3. So that's why I will have a to the 1/3 power. Okay, now how about the b's? So for the b's, I have negative 1/3 minus 5 over 2. I need like denominators, so I'm going to do this by 2. I'm going to do this by 3. So that's going to give me negative 2 over 6 minus 15 over 6. Alright, so that's going to be negative 17 over 6. So that means I will have b to the negative 17 over 6 power. And that just, the c, that just leaves the c up there, so that's still going to be c to the 8 over 3 power. Now this is not okay. Well, to be more precise, the a and the c are fine. They are fractional powers, but they're positive, so they will stay in the numerator. But the b factor with the negative exponent will drop down to the denominator, and then now I will have a fractional power in the denominator. And that, my friends, is against the rules. We cannot have that. We cannot abide that. So here's how you fix it. Focus on the negative 17 over 6. So I've got negative 17 over 6. I need to add a whole number to this that will give me a positive result. A whole number would be like, for example, 6 over 6, because that's 1. But that's still going to give me a negative number. So I got to go bigger than that. What about 12 over 6? Because that has a value of 2. Nope, still negative. Okay, what about 18 over 6? Because that has a value of 3. Ding, 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 that works. Negative 17 plus 18, that is 1. So that's going to be 1 over 6. Now, as soon as you find one that works, subtract it from both sides to move it over there. So that is going to give me negative 17 over 6 is equal to 1/6 minus 18 over 6. Now understand that that is the same thing as negative 17 over 6 is equal to 1/6 minus 3. Remember? So this is the fact that we will use to rewrite the b term. Okay, so I'm going to split this b term, this b factor up into 2 factors using these 2 exponents. So this would be the same thing as having b to the 1/6 power times b to the negative 3 power. And I believe you can convince yourself quickly, if you multiply these 2 back together, you would have to add these, and you will get negative 17 over 6. And you know that because you see it right here. You put these together, you get negative 17 over 6. Okay, that's how you fix the problem, people. Because watch how we fixed it. So first of all, I'll go ahead and bring down the a to the 1/3 power again, and I'll bring down the c to the 8 over 3 power. So now this fractional exponent is positive, so it will not drop down to the denominator. The only thing that's going to drop down to the denominator is this, but that's okay because it is not a fraction. Okay, so that's going to drop down to the bottom. So that's why my final answer to number 21 is going to be a to the 1/3 power times b to the 1/6 power times c to the 8/3 power all over b to the 3rd power. So this will be the final answer for number 21. Okay, let's do one more problem. Alright, number 22. Looks like a monster. There's nothing to do in the numerator. There's only one of each. So I'm just going to copy that down the way it is. So in the numerator, I've got h to the 1/4 power, j to the 4th power, and k to the 7/4 power. Nothing I can do with that. So I'm working the denominator. First thing I need to do is raise all three of these things to the 1/2 power. When you do a power raised to a power, you multiply. So this is going to be h, but a 3/2 times 1/2, that's 3/4. Alright, now the j. Negative 3/2 times 1/2, that's negative 3/4. And now the k. Well, negative 2 times 1/2 is negative 1. So that's just going to be negative 1. So I've got this, but don't forget the rest of this over here. So I've still got times h to the 3rd power, j to the 7/4, and k to the 1/4. Alright, I've still got all of that. So I'm still working on the denominator. Now that the parentheses are gone, I can put these together. So when I multiply the h's, for example, I need to add the exponents. So first of all, the numerator is not changing, so I recopied it. So when I multiply these h's, I need to add the exponents. So I need to do 3/4 plus 3 over 1, like denominators. So that's going to be 3/4 plus 12/4. So that's going to be 15/4. So that's my h's. So I'm going to have h to the 15/4 power. Alright, let's do something similar for the j's. Okay, for the j's, well, you know what, the j's already have like denominators. So negative 3/4 plus 7/4. Isn't that 4/4? Which is just 1. So this is just going to be j. I meant that to be red. Alright, that's just going to be j. Okay, that was fun. So anyway, with the k's then. Alright, let me just get ready. Get ready for the k's. I've got negative 1 plus 1/4. Okay, like denominators. So that's going to be negative 4/4 plus 1/4. So that's negative 3/4. Alright, so there's that. So now we're at the stage where we need to divide by subtracting the exponents. So looking at the h's, I need to do 1/4 minus 15/4. So that's going to be negative 14 fourths, which is negative 7 halves. So that gives me h to the negative 17 over 2 power. Alright, for the j's, 4 minus 1 is 3, which we already knew. So that'll just be j to the third power. Alright, now for the k's. I've got to do 7 fourths minus negative 3 fourths. Do you see the double negative happening here? The top minus a negative. When you do minus a negative, it is addition. So this is really going to be 10 fourths, which reduces down to 5 halves. Okay, so this will be k to the 5 over 2 power. Alright, 2 of these are fine, 1 of these is not fine. The h to the negative 7 over 2 power is not okay. Because it is a negative exponent, it will drop down to the denominator, and then I will have a fractional power in the denominator, and that's not allowed. So it's time for me to once again show you how to fix that. Here's what you do. Start with negative 7 over 2. I need to add a whole number to that is going to give me a positive result. For example, well, I have a denominator of 2, so I'm kind of stuck with that. But so I could do 2 over 2 because that has a value of 1. But that would still be negative. That would be negative 5. So that's no good. So I have to go bigger. So what about 4 over 2? Alright, because that has a value of 2. Still negative, that's negative 3. Got to go bigger. Go big or go home. What about 6 over 2? Alright, because that has a value of 3. That's negative 1, so I'm almost there, but I still got to go even bigger. What about 8 over 2? Because that has a value of 4. That's going to work out. Negative 7 plus 8 is positive 1. Positive 1 over 2. As soon as you find one that works, you need to subtract it from both sides. Move it over there. So that's going to give you negative 7 over 2 is equal to 1/2 minus 8 over 2. Okay, but 8 over 2 is 4. Never forget that. So this is really 1/2 minus 4. And this is the fact that we will use to rewrite the h factor. Okay, let me just move this stuff out of the way. So what I can do is I can split this h factor apart into 2 h factors using these two numbers as the exponents. So we'll rewrite this as h to the 1/2 power times h to the negative 4 power. Alright, I just split that h apart into these two. And I'll just bring down the rest. So I will bring down the j to the 3rd power, and I'll bring down the k to the 5 over 2 power. Alright, take a moment to convince yourself that I have not changed anything. If I were to multiply these two together, I'd have to add the exponents. And I'm saying if I add these exponents, I'm going to get negative 7 over 2. And you can see that right here. If I add these two numbers together, you see that they equal negative 7 over 2. Okay, so now it's time to write the final answer. We solved the problem of having a fractional power in the denominator. The only negative exponent is this one now. And this can drop to the denominator all at once, because that'll be a whole number. That'll be a 4. Alright, all of my fractional powers are now positive, and they stay in the numerator, so everything is good. Okay, so the final answer. So the final answer should be h to the 1/2 power times j to the 3rd power times k to the 5 over 2 power over h to the 4th power, because that's the one that dropped down. So this should be the final answer for problem number 22. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.